Hello and welcome to Tovi. This tutorial is going to cover the energy balance residual correction. Now before we get started, we're going to go ahead and enter into our dashboard tab to pull up the energy balance dashboard. Now this dashboard lets you look at the individual energy components. So you can see we have our sensible heat and our latent energy, the two variables derived from the eddy covariance system, and some independent energy balance variables, our net radiation, and our soil heat flux. You can see I can pick from various number of individual sensors, gap-filled sensors, and averaged variables. Now here in this particular plot, you can see that an ideal energy balance has a slope of 1 and falls on the red 1-to-1 line. Now you can see that this data set with the yellow line shows a slope of 0.8, or about a 20% underestimation. Now this underestimation is quite common in the community at various ecosystems where eddy covariance measurements are made. And the leading hypothesis is that the sensible heat and latent energy components are underestimated, and potentially they're not really fully captured by eddy covariance systems. So there's several methods out there that are being proposed to correct for this imbalance. The main difference between these correction methods is how to reapply this residual energy back into the H and LE terms so that you do have an ideal closure, or something close to that. These residuals can either be equally applied to both H and LE, or they could be weighted, for example. So in 2019, we did a collaboration together with Matthias Mauter to compare eddy covariance results with independent measurements that people had at their sites, in particular of latent energy or evapotranspiration. So Tovi was used as a tool in this collaboration for evaluating the existing methods and doing some analysis to determine which should be recommended and which should be used by the community. So before accessing this tool, we go back to our overview page. Before using the tool, you'll want to make sure that you've gone through a QC screening session where you've cleaned out your sensible heat and latent energy, along with the soil heat flux, net radiation, those types of variables. Then you will have gone through the gap filling tool to make sure you have a full complete data set for your air temperature and your soil heat flux terms. Then you'll want to go into the storage correction tool. Now, if you had the appropriate measurements, including a soil temperature probe that's located between the soil surface and the soil heat flux plate, you can compute the soil heat flux storage in the soil. And then you can correct for your soil heat flux and get the soil heat flux at the surface rather than at the plate down buried below the surface. Then you can use the averaging tool to go through and make sure you have any redundant variables or multiple measurements averaged into single variable terms to use. And finally, if this is optional, but if you want to use the footprint tool, you can also screen out some data that's not included in your footprint. So let's go into the toolbox and find the energy balance residual correction tool here. And if we click on that, what you'll notice is at the top here we have 4 different correction methods. Now if you want to learn more about these, you can come down to this acknowledgement icon, and in here are the publications that are used inside this tool. And if you want to see even further details, you can click here and see the various authors that were contributed and some links for them in case you want to reach out to them with any questions. Okay, so you have some options here. You can decide to select just one of these methods, or you can go through. And in this exercise, I'm going to select all 4 correction methods so I can evaluate which works best for my site. Now we can come down to the settings here. And for the air temperature, I'm going to select the gap filled temperature that I originally did in the gap filling tool. Then this Obakov length, that is determined and computed by EddyPro, and that's in the file, so I'm just going to leave that as it is. Then down here we have our dependent energy terms from the eddy covariance system, our sensible heat, and our latent energy. And we want to make sure that we do not use gap-filled variables in this tool. We're trying to use the real collected data for this correction. And then down here we have our independent measurements. So in here I have various soil flux measurements. Here's one that I've done the storage correction on, as well as averaged into a single soil heat flux variable. And then here I can select gap-filled net radiation variable. Over here we have the choice to change the time scale for which we want to do this evaluation. I'm going to leave it at 24 hours. And I'm going to go ahead and leave this minimum net radiation value set to 20 watts per meter squared. Now when I'm ready, I can come up here and just click on this start button. And within a minute or two here, you will see the results pop up. Okay, now here we are on the results page. You can see we can look at our sensible heat terms, or we can look at our latent energy terms as well. Down here we have a time series plot that shows the uncorrected sensible heat values, as well as the various corrections, which you can turn on and off to have a closer look at the variables and see the corrections. Down here we have 4 panels. Now each of these 4 panels are the 4 different correction methods. Now each one of these show a daily ensemble average of the difference between the uncorrected and corrected values for both sensible heat and latent energy. So this first one here is from the 2013 Mauder publication. And in this methodology, the correction maintains the sensible heat to latent energy, or the Bowen ratio, the same both before and after the correction. The Cherachudapan paper from 2014 has a different methodology, and in it, the methodology here applies almost all of the correction to the H, or sensible heat term. And the theory is that the eddy covariance system misses some of those large-scale structures. And you can see that shown in the chart here with just H. Now down here you can see the 2 plots from the Daru publication 2018, in which the methodology there uses large eddy simulations, or LES, and H and LE are partitioned depending on height. And one of these methods, the scaled method here, or the A version, pushes for closure, while this other one does not. Now over here you can see that we have the 4 energy balance plots showing the new corrected values for each method. As you can see now, the slopes are much closer to the ideal 1 line, and where previously that was at 0.8. So now what we can do is either decide to go back to the settings and change some of the variables that we used, or perhaps only choose 1 or 2 of the corrections. Otherwise, we can go ahead and click right here to execute this tool. So here I have a previous run analysis where we can look at the results. When I'm back here on the overview page after running the tool, I can click on this flux group of variables. And what you'll notice now is I still have my original sensible heat and latent energy variables, but now I have 4 new latent energy variables computed with the various correction methods, and similarly 4 new sensible heat variables as well. Now if I go ahead and go back into my dashboard and go to the energy balance dashboard, what you'll notice now is in my sensible heat drop-down list, I can pick the corrected variables that came from that tool. I'll go ahead and select the same net radiation and soil heat flux. And now I can see the new results for my data set here. And you can see the slope now is, when previously it was about 0.81, it's now at 0.99. And we have a nice set of data with some nice closure for this particular data set. And with that, this concludes this tutorial.